Hello and welcome back to my channel. Today we're going to be looking at the 2010 AP Calc free response problem about stuff from Unit 8. So we're going to kind of go through each part separately and kind of see what's going on. So let R be the region in the first quadrant bounded by the graph of y equals 2 times the square root of x, the horizontal line y equals x, and the y-axis as shown in the figure. So one of the first things that I would do when I'm looking at this problem is I would label which equation is which. So this equation right here is going to be that 2 square root of x. This is y equals 6, and then the y-axis is the y-axis. So the first thing that we need to do is find the area of the region R. So when we're looking at area, we have to remember that we are looking at the top equation minus the bottom equation. We're doing this in this direction. So I need to take that equation y equals 6, and I need to subtract it from 2 times the square root of x. So our top equation is y equals 6, our bottom equation is 2 square root of x. Looking at my bounds, I know that I'm starting at 0 and I'm ending at 9 for x. So one of the things to keep in mind, this is a no calculator question, so whatever we do, we have to do without a calculator, meaning we have to solve for the integral when we do this problem. So our area is equal to the integral from, we saw that it started at 0 and ended at 9, so it's going to be from 0 to 9 of top minus the bottom equation. So our top equation, like we said, was y equals 6, so we have 6 minus the bottom equation, which is 2 square root of x dx. Now what we're going to do is integrate this. Before I integrate it, I'm going to go ahead and change the square root of x to be 2 times x to the 1/2 power. Just to make this a little bit easier. So we integrate 6, this is now 6x. We add 1 to our exponent and divide by it, so I have 2 times x to the 3/2 power, and we're going to be dividing by 3/2, but dividing by 3/2 is the same thing as multiplying by 2/3, so I'm going to do that instead. And we need to evaluate that from 0 to 9. So I'm going to simplify my coefficients just a little bit and then evaluate. So we have 6x minus 2 times 2/3 is the same thing as 4/3 x to the 3/2. And now we kind of need to work through what we have here. One of the things that we want to remember is that 3/2 is the same thing as the square root of whatever our thing is cubed. So sometimes taking the square root first is helpful, sometimes it's not. I can kind of interchange which one I'm doing when. So if I want to do the square root of a number first, I can, but I could also cube that number before square rooting it. Now we're going to use FTC number 1 and plug in 9 and plug in 0. So we have 6 times 9 minus 4/3 square root of 9 cubed minus 6 times 0 minus 4/3. And for space, I'm going to do 0 to the 3/2 power. Thankfully, everything on this side is going to go to 0. 6 times 0, 4/3, 0 to the 3/2 power. All goes away. So I'm left with everything on this side over here. So we have 6 times 9, which is going to be 54, minus 4/3 times 9. The square root of 9 cubed. The square root of 9 is 3, and so we're looking at 3 cubed. So we have 54 minus 4/3 times 27. 3 times 3 times 3. I could also kind of manipulate this a little bit because we are dividing by a 3 and multiplying by 4, so I could really do 4 times 3 squared. So we have 54 minus, I'm going to divide 27 by 3 to get 4 times 9. 4 times 9 is 36. So I have 54 minus 36, which gives us 18. So for our first problem here, we should get an answer of 18 by going through all of this work. The other thing that's good to know is how they might score this. So in this particular question, this problem, this part is worth 3 points. The first point is going to be awarded for what you are taking the integral of. So the first point is going to be awarded for all of this here. Our second point is going to be for the appropriate antiderivative. So it'd be somewhere in this area. You could stick with the first one or the second one and be fine. And then the last point is going to be for our answer here. So our 3 points are kind of like beginning, middle, and end, but not every AP problem is going to be worth 3 points.